Hello, everyone. My name is Kaylee Carlson. This is my nutrition research project. The subject is how does creatine monohydrate supplementation impact lean muscle mass performance in high intensity exercise? So, just a quick background of what creatine monohydrate is, what we'll refer to as creatine. So, creatine monohydrate is a form of creatine similar or identical to endogenous creatine that is naturally produced in the liver, kidneys, and the pancreas. It's a naturally occurring compound. It's a primary constituent of phosphocreatine, which is PCR. That does provide cellular energy for the muscles. So, in a phosphate form, or PCR, creatine helps to supply energy to the muscles for contraction. Just a quick overview of how it works, because we'll go more in depth later. ATP deposits are depleted after an intense muscular effort, and then a creatine phosphate donates phosphate groups towards the quick synthesis of ATP. The NIH has found that supplementation may improve muscle wasting associated with cancer and other chronic diseases. So that's just a little fun fact about how creatine can be used. You can see to the lower right here the creatine monohydrate molecular structure as well. So, how much has it been researched? It's one of the most heavily researched health supplements with over 1,000 studies regarding its safety and its efficacy. The research that's been conducted has determined that the use of creatine can lead to increased strength, increased muscle mass, improved performance, and increased fatigue resistance as well in the muscles. How exactly do we acquire creatine? So, as I mentioned, it is produced in our body naturally in our pancreas and our liver um, from the amino acids glycine, arginine, and methionine. We can acquire it from our diet, which is primarily animal products, where creatine comes from. So you would see that in red meat, seafood, poultry, and dairy products as well. And then a large contributor would be creatine supplements. The main form that's the most researched and accessible is creatine monohydrate. There is creatine HCl and creatine ethyl ester as well, but what we'll dive into today is creatine monohydrate. To the upper right, you'll see this image of what we're looking at mainly here is the liver and the pancreas here behind the stomach. So just to kind of know where exactly in the organs this creatine is coming from. The different forms you can find it in as a supplement would be hydrolyzed powder, gummy form, and then capsules. Creatine monohydrate is a water-soluble supplement, so doesn't have to be taken with food. I'll mention later on a way to optimize the absorption of creatine monohydrate, but it does not have to be taken with food. The only thing to keep in mind with if you're taking gummies as the supplement form would be potential development of cavities due to the higher sugar content of the gummies. So that's just something to keep in mind with any gummy vitamin though that applies. So where is creatine monohydrate stored in the body? 95% of it is stored in skeletal muscles to be used when the body's performing physical activities or voluntary movements. So not muscular movements like breathing or the heart beating, those are different types of muscles. We're looking at skeletal muscle, that's where it's stored. So, muscles like the biceps, or down here to the left, you can see muscles engaged in lunges. So, the gluteus maximus, the quads, the hamstrings, that's kind of what we're looking at where the creatine is stored. And then here is a diagram of skeletal muscle on a smaller level. So, you can see all the different fibers and components there. And then this is just an overview of how broad the skeletal muscle is, covering the entirety of the body. So, what's the usable form of creatine? Because it's not just powdered creatine, it has to be converted to phosphocreatine or PCR. That is done by the enzyme creatine kinase. And then PCR is sort of like your energy reservoir for adenosine triphosphate, or commonly known as ATP. So that's what you can kind of see here is that PCR, ATP here. We'll discuss in a little bit how ATP will convert to ADP, releasing energy for it to become PCR and then become usable for the skeletal muscle. So here we'll discuss ATP and the mitochondria. As you may remember from middle school biology, the mitochondria is the powerhouse of this cell. So this is where, on a cellular level, a lot of energy is coming from. So ATP is broken down into ADP, and as I was saying from that last diagram, the energy through this process is released uh, to the skeletal muscles in the usable form, so that they can use that energy. So we can refer to all of this as the PCR shuttle. It's a shuttle system. It's a metabolic system that occurs when the transport of high energy is facilitated from the mitochondria and the skeletal muscle cells into the myofibrils. So consumption of creatine increases the amount of creatine in the skeletal muscle cells that can then be converted into this PCR usable form. The increase in resynthesis of PCR is super useful for supplying skeletal muscle cells with a significant increase in energy during high intensity exercise. So this is that shuttle system over here. And then that is your enzyme here in the middle, helping to convert the energy into the usable form. We can then see muscle contraction as the result over here. So, like everything, there are always risks. So, risks of taking creatine monohydrate as a supplement could be dehydration, digestive complications or indigestion, muscle cramps, which kind of goes hand in hand with dehydration, and potentially kidney damage. That's mainly found in individuals who have pre-existing chronic kidney diseases. Just something to keep in mind to prevent and minimize these risks, though, you would want to follow the recommended dose, which is 3 to 5 grams per day. You can start out with a lower dose to begin and increase gradually as your body adapts to it. It's important to consult with a primary care physician before taking really any supplements, but creatine as well, because it can depend on each individual how much would be ideal for you to take. So, not everyone is the same, so it's best to see your physician if possible. It's also recommended to take creatine with a meal if you can, one that is higher in carbs or protein, as that can boost the body's ability to absorb creatine. So you can just take it with water, and it will still be absorbed into the body, but having something with carbohydrates and protein will optimize the absorption. So, why exactly is creatine relevant? It's important for us as humans to know about it because it's a chemical in our body that's naturally produced that fuels our muscles on a day-to-day basis. But consumption of it through our diet and especially supplementation can maximize the energy potential for our skeletal muscles during high intensity exercises. Every human will benefit from creatine as it's produced by our bodies for muscular function, of course, as long as there's no extreme contraindications that would cause health issues. But it can be extremely useful for athletes, endurance athletes, weightlifting, high intensity interval training, etc., because it will aid in shortened recovery time and increased energy output to the muscles during exercise. I don't believe I'm biased on this topic, as I do like to be pretty skeptical about nutritional supplements. However, I do work as a personal trainer and I'm passionate about learning about the body and movement, and it's something that I do hear discussed a lot amongst my peers in the fitness world. So, a myth with creatine is that taking it will make you shredded or lean. It does support and optimize lean muscle growth, but this only happens when skeletal muscles are being used in high intensity exercise on a consistent basis, which stimulates the synthesis of the muscle fibers. So just being sedentary and taking creatine is not going to inherently build your muscles and make you leaner. It has to be paired in conjunction with exercise and breaking down those muscles so they can be built back up. It can actually increase body weight on the scale and create an appearance of fullness. This is just because it can lead to water retention in the body, which may lead to an illusion of fat gain. So, in summary, creatine supplementation is fundamental to supplying additional PCR, which then assists with and facilitates the PCR shuttle system, increasing energy accessibility for skeletal muscle. There are potential risks of taking creatine supplements. They're variable depending on the individual's pre-existing health conditions and medications that may increase risk of dehydration. It's best to consult with a primary care physician prior to supplementing with creatine in order to ensure that it's a safe option for you. And then here are my research resources as well, for all the data that I was able to find about creatine. So feel free to look through that. Thank you for listening to my presentation, and I look forward to hearing any questions and comments about this topic.